Dr. Hall, good morning.
Good morning, Sylvie.
Thank you for doing that. Giving us this interview and this update on the research that the foundation is currently funding on the melanoma project. It has been a while now that at the foundation we are speaking of melanoma. Would you mind to give us an update about what we have achieved, where we stand, what are the results we have obtained so far, and why are we so keen at researching melanoma?
Well, first of all, we are pursuing yet another hard-to-treat cancer. We've researched ovarian cancer, pancreatic cancer, which are hard to treat, hard to survive, and there has been a need for alternative treatments that are non-toxic and that are effective. So for example, Paulo Pereira works against these cancers, as does Revolfia vomitoria. Melanoma is the most serious form of skin cancer. And if it's not caught early and surgery is effective early, the prognosis is terrible. And that means that there's a great need for new effective therapies that work and that are non-toxic. But we're taking a different approach here. We're looking at the yellow leaf ginkgo extract or the golden leaf ginkgo extract that Beljanski developed because it holds promise, we think, to be a treatment for melanoma. And the focus of this research is on a process called angiogenesis. And that's the method by which cells recruit blood vessels so they can grow, divide, and develop tissues. This is a healthy process normally, but cancer cells have hijacked it. And the cancer cells now use the signals that normal cells use to create blood supply so that the tumor can grow and advance. So this process of angiogenesis is one of the strategies cancer cells use to grow and spread, and we would like to address that. And this is a little different, it's significantly different from killing cancer cells, which is a desirable goal, and we already can do that with the extracts I just mentioned. The ginkgo extract does not have a cytotoxic effect, a significant cytotoxic effect against these cancer cells, but I think it may, and our hypothesis is that we can interfere with the development of blood supply for the cancer.
Last year, you talked to us about melanoma already, and you were mentioning at the time some research done with green tea extract. And it is my understanding that the culmination of that research program was a publication. So can you tell us what we achieved with the tea and why we are moving now to the golden ginkgo?
Well, one of the cancers that Dr. Chen's group looked at was melanoma, looking at the tea, the effect of the tea on those melanoma cancer cells. And there was an impressive result there because 4 different melanoma lines were tested, and the combination of green tea extracts were effective against all 4 melanoma lines. And this is, again, a broad spectrum anti-cancer effect because that green tea combination is also effective in the experiments done at Kansas against breast, bladder, and liver cancers as well. But the melanoma cancer, as you can see from what I just said, is very much our focus and what we're focusing on. And that has led us to take this new and very interesting approach using the potential of the golden leaf ginkgo to see how it can be used as an anti-cancer agent. And we're focusing specifically, of course, now on melanoma.
So what you are hoping to do this year is another approach from what we have done with the tea last year. And it's going to be cumulative. I mean, people are going to be able to use both the tea, green tea, and the ginkgo extract, right? And what we are going to show is that they are not working the same way, but it is 2 different cumulative pathways, right?
Yes, and the important thing is to combine these different approaches. So cytotoxicity to cancer cells, selective cytotoxicity, is one very valuable goal. We have achieved that with the Palpera and Rolfia vomitoria and with the green tea combination. What we want to bring in is a second mechanism of action, which will provide the opportunity for synergy and provide an additional line of attack against these cancer cells. Now, the reason why we focused on ginkgo goes back to Dr. Mirko Beljanski's work, and he showed that the yellow leaf ginkgo extract is a regulator for a family of enzymes released by skin fibrosis, cells undergoing skin fibrosis. Radiation damage induces hyperactivity of a family of enzymes called RNases. And we've been focusing on that. And the group, Dr. Chen's group at Kansas, has started to focus on these RNases, which are first detected in skin fibrosis. But Beljanski also found 3 cancers that release these RNases: breast, pancreatic, and leukemia. And what Dr. Chen has done is show that melanoma cells release these RNases. And that's a complex issue right there, because there are at least 15 different enzymes in this family that are secreted. And one of them is of particular interest to us. It's called angiogenin, because that is the signal that the cells use to generate the blood supply.
What are the other kind of cancer cell lines that can be affected by angiogenin?
Well, I think it's going to turn out to be, are there any cancers that are not affected by it? We don't have a complete list, but every time I look in the literature, I find another example of angiogenin released by another cancer cell that can help develop blood supply. And our goal then is to inhibit that process and thereby stunt the growth of the tumor.
So that means that this research that we are now conducting on melanoma could actually, on the long run, be applied to a number of cancer cell lines, right?
Absolutely.
Okay, that's really important and promising. So do you have an idea of how much this phase of research is going to cost, and how long is it reasonable to expect is going to last?
Well, let me jump in and just say the first step of the experiments at Kansas have been completed. And what Chen's group did was demonstrate the effect of the golden leaf ginkgo extract. So the golden leaf ginkgo extract does, as we expected, based on Beljanski's work, it reduces the activity of these secreted enzymes. So this is step number 1, and it's been a success. The problem I just alluded to, there are a lot of enzymes in there. There are RNases, and of course, angiogenin is one of those RNases. So step 2 of this experiment is to find out whether or not golden leaf ginkgo specifically inhibits angiogenin among all these different enzymes. We need to nail down the specific effect of the ginkgo extract on the activity of angiogenin, which can thereby, we can proceed in further steps to see whether or not we see the biological effect. Because if we're reducing angiogenin, we should thereby be reducing blood supply to the tumor. So the step 2 is a budget of $16,500. And that's what we're trying to raise money to do. And I hope I'm conveying how important this is. We have an opportunity here to use a plant extract, which is well established as a therapy for skin fibrosis, but to switch into the cancer domain and have this very, very attractive interruption of suppression of blood supply to tumors.
And then nothing will often prevent us to study a combination of both the green tea and the ginkgo leaves, because if they have 2 different synergistic approach, that should yield excellent results for melanoma.
Yes, I think you could go into animals and have a real model for human tumors, a melanoma model, and find out what the combination does. You put in ginkgo, plus you put in, say, the green tea extract, and see if you get the synergy. And in that context, you can also confirm the in vivo activity of the ginkgo extract on blood supply to the tumor, suppression of that blood supply.
And then, as you said, this could be applied to other kind of cancer.
That's right. This is a general mechanism that cells use under normal circumstances to recruit blood because they need to grow and divide. Say, for example, brain cells in development. They need blood supply. They can send out angiogenin and get some blood to grow as the brain needs to develop. But as I said earlier, the cancers are very effective at hijacking normal processes in order to enable their own survival.
That's fascinating. Thank you, John.
You bet.